thought I'd do a couple more examples in addition to the stuff we did in class as far as balancing equations go. Stuff you can look at over and over and see how these things are done. I've set up my ARP table, and I've got my my equation here that I've got to balance, and let's go ahead and get started. What I'm going to do is I'm going to count up. Actually, before I count up, I'm going to identify my atoms. So I've got magnesium, I've got sulfur, just reading from left to right, I've got hydrogen, and I've got chlorine. Double check, make sure I got the same stuff on the other side. I got magnesium, sulfur, hydrogen, chlorine. Yeah, it looks pretty good. I'm going to go ahead and start counting things. I've got magnesium, 1. There's my subscript or absence thereof, which is understood to be a 1. And I've got 1 on the product side. 1 magnesium here, 1 magnesium here. Sulfur, I've got 1 here and 1 there. Hydrogen, again, I'm looking here and here. On the reactant side, I've got 1. On the product side, I've got 2. That subscript 2 tells me I've got 2. Chlorine, I've got 1 on the reactant side, 2 on the product side. So I've got 2 things out of balance. I've got hydrogen and chlorine that aren't in balance. I'm going to start with fixing the hydrogen. I've got 2 over here and 1 over here. So I ask myself, what times 1 gives me 2? Answer is 2. So I put a 2 out in front here. That 2 has to go in front, can't go in the middle. Can't go in the middle because what I've got is I've got a hydrogen atom and I've got a chlorine atom stuck together. So if I put that 2 or try to put that 2 in the middle, it's kind of like trying to break those 2 atoms apart. That's not what's going on here. Those guys are bonded together. They're not coming apart. I can't put it here. That 2 here is a subscript because that 2 would say that hydrochloric acid is H2Cl. And that's not true. Hydrochloric acid, the formula is HCl. If H2Cl doesn't even exist. So I take care of putting in that coefficient, and now I take a look at what it changes. It's going to change my hydrogen, it's going to change my chlorine, so I erase those guys, and I'm going to recount my hydrogen and chlorine. I now have 2 times 1. This 2 gets multiplied by everything that's in front of it. It's almost like putting imaginary parentheses around it, and just like in math class, I'm going to distribute that 2 to everything inside of there, or to everything in front of it. Let me get rid of those. I don't need them. They were just illustration. So it's 2 times 1 gives me 2. 2 times 1 gives me 2. And this one balanced pretty quick. This guy is now balanced. Let's go ahead and take a look at another one. Sometimes they don't work out that quickly. So I've got another equation to balance, and I've set up my ARP table already. And I'm ready to go ahead and identify atoms. I've got calcium, and I've got phosphorus, I've got oxygen. Notice I'm taking this phosphate ion and I'm breaking it into its pieces, phosphorus and oxygen. I've got carbon, I've got silicon, and I've got oxygen again. I've already got oxygen covered here, so I'm not going to write it down again because I've already taken care of it. Now I will have to make note that I've got oxygen in 2 places, so when I go to count them up, I'm going to have to be careful and take note of both places. I'm ready to go ahead and start counting. I look at my subscript. I've got 3 calciums here. I've only got 1 calcium over here. I've got, inside the parentheses, I've got a phosphorus, so that subscript is understood to be 1, just like in math class, this 2 gets distributed, multiplied by everything inside of there. So I take 2 times 1 to give me 2 phosphorus. Over here I've got 4 phosphorus, subscript of 4. Oxygens, I've got 2 times 4. 2 times 4 gives me 8 phosphorus from the calcium phosphate, but I've got another 2 over there, so plus 2 gives me a grand total of 10 oxygens on the reactant side. On the product side, I've got 3 here, plus another 1 here, so it gives me a grand total of 4 oxygens there. Get rid of those. Get confused later. All right. Let me keep counting. I've got one carbon here. I've got one carbon over there from the carbon monoxide, subscript of 1. Silicon, I've got one here, and I've got one smack in the middle of this one. So I'm ready to go ahead and start balancing. I've got a couple of choices. I've got my calcium, I've got my phosphorus that are out of balance. I've got my oxygen. I said in class we typically hope that oxygen will balance itself, and we'll just leave that till the end. So let's go ahead and either balance the calcium or phosphorus. Looking at this, I'm thinking the phosphorus looks a little easier. I got a 4 here, I got a 2 here. I think I'm going to start with the phosphorus. Why? Just kind of a gut feel. So I'm going to put a 2 here, and so that's 2 times 2, it's 2 times 1, so it's 2 times 2 gives me 4 phosphorus. And oops. Let me go ahead and check what's going to get affected. My calcium is going to get affected, my phosphorus is going to get affected, I already changed that, and my oxygen is going to get affected, so I'm going to erase those guys so I can fill those in. Calcium, I've got a 3 here, times 2 gives me 6 calciums. My oxygen, I've got 2 times 4, so it's 2 times 4 times 2 again, which is going to give me 16, plus I've got 2 from my silicon dioxide, which takes me up to 18 oxygens. Numbers are getting kind of big, but hopefully they'll work out in the end. All right, so next thing I got to do is take care of my my calciums. Those are still out of balance, along with my oxygen, but again, I'm saving that for last. So let's see here. Let's go ahead and take a look at the calcium. I've got 1 calcium over here. I've got 6 calciums over here. What times 1 gives me 6? Well, the answer is 6. So that's going to affect my calcium. It's going to affect my silicon, and it's going to affect my oxygens. So I'm going to go ahead and count these up now. I've got 6 calciums, 6 times 1. I've got 6 silicons, 6 times 1 gives me 6. And then I've got 18, because I got 3 times 6 is 18, plus another 1 gives me 19 oxygens. Not real pretty, but we'll see what happens. Hopefully those will get fixed up. Where am I at? I guess my silicons are going to get fixed next. So let's go ahead and fix those. I've got 1 here, 6 here. What times 1 gives me 6? The answer is 6. That will affect my silicon and my oxygen on the reactant side. Let's go ahead and recount. 6 times 1 gives me 6 silicons. 6 times 2 gives me 12 oxygens, plus another 2 times 4 times 2. That's 8 times 2 is 16 oxygens for my calcium phosphate. Grand total of 28 oxygens. So that leaves me with just my oxygens to fix. Now, I've got oxygen in 2 places. I've got it with this carbon monoxide. That carbon is by itself. If I can just get this to balance out the oxygens, I would be in much better shape because I can do whatever I want to this and it won't affect anything else. So let's see here. This one is this carbon monoxide. So if I could just make that a 10, which I can, if I take 10 of these, what I wind up with for my oxygen, that's going to change my oxygen, so let's fix this. And my carbon, those are the 2 things that are going to be affected. What I wind up with is 6 times 3 is 18 carbons, plus 10 times 1 gives me my 10 oxygens there. Sorry, I think I said 18 carbons, I meant 18 oxygens, plus my 10 oxygens over here gives me a grand total of 10 plus 18 gives me a grand total of 28 oxygens. So those guys balance. The only thing that's still out of balance is my carbon. I go over to the reactant side. I've got carbon right here. what times 1 gives me 10? The answer is 10. So that gives me 10 here. And the only thing that gets affected when I change that is my carbons. So I get 10 there. And now this is balanced. A little trickier because I had to recognize, that I had to do something to the carbon monoxide to get that to balance. Let's try one more. I've got my last example here. Let me go ahead and identify my atoms. I've got aluminum, I've got hydrogen, I've got nitrogen, and I've got oxygen. Aluminum, hydrogen, nitrogen, oxygen. Let's start counting. I've got one aluminum here, I've got two aluminums here, I've got one hydrogen on the reactant side, two on the product side. Nitrogen, I've got one on the reactant side, I've got one on the product side. Oxygens, I've got three on the reactant side, and I've got 3, 4, 5, 6 on the product side. I'm going to save aluminum over here on the reactant side because I can do whatever I want to this and it won't affect anything else. So I'm just going to kind of hold off on that. I think what I'm going to start with is this hydrogen. So 2 times 1 gives me 2, so that's going to affect my hydrogen, my nitrogen, and my oxygen. So we'll take that to 2 times 1 gives me 2 hydrogens. 2 times 1 gives me 2 nitrogens. 2 times 3 gives me 6 oxygens. Not bad. The only thing that's out of balance is my nitrogen. So I'm going to go over to the other side and figure that what times 1 gives me 2? The answer is 2. So that's going to change this and this. So 2 times 1 gives me 2. I've got 4 oxygens here, plus another 1 here, plus another 3 here. That's going to be 8. Okay. 1, 4, that's 8. So the only thing that's left to do is fix the oxygens. And I'm going to need more oxygens on the reactant side. So the only thing that's containing oxygen is this nitric acid. I've got a 2 here. I'm going to change that to a 3. That would be the next logical number to go to. That's going to affect my hydrogen, my nitrogen, and my oxygen. Let's go ahead and count those up. Hydrogens, 3 times 1 gives me 3. 3 times 1 gives me 3 for the nitrogens. 3 times 3 gives me 9. Oops. 9 for the oxygens. All right, my hydrogen and my nitrogen are back out of balance. So I think I'll try to fix my hydrogens by putting a... No, you know what? I think I'll try to fix my nitrogens. That might be easier. So let's go ahead and put a 3 here, because what times 1 gives me 3? That'd be a 3. So that's going to affect my nitrogen and my oxygens. So I wind up with 3 nitrogens. And the oxygens, I've got 1 here. I've got 2 times 3 is 6 there, and another 3, that's 9. That's 10 oxygens. I still have hydrogen to fix, so let's see what happens. I'm just going to keep going. Some of these take a while on occasion. I need more hydrogen over here. The only thing it contains is the water. Right now I'm sitting at a 1 for a coefficient. The next logical number would be to go to a 2. So what I'll do is that'll change my hydrogens and it'll change my oxygens. Let's count it up. 2 times 2 is 4. The oxygens, I've got 2 times 1 is 2, plus another 6, 2 times 3, plus another 3, that's 9, 10, that's 11 oxygens. Boy, those oxygens are stubborn. And I still have hydrogen to fix, so I guess I've got to fix this. This is going to be, for my hydrogens, I've got 1 times what gives me 4. So I'm up to a 4. It was at a 3. I'm just going to jump that up to a 4. That's going to affect my hydrogen, my nitrogen, and my oxygen. So I've got 4 hydrogen, 4 nitrogen, 4 times 1, 4 times 1, And then 4 times 3 gives me 12 oxygens. Boy, those oxygens are stubborn. All right, I guess I'm going to go over to the other side, and I'm going to make this, the next logical number would be to make it a 4. So that's going to change my nitrogens and my oxygens. Hopefully this will balance things up. I've got 4 nitrogens. And then my oxygens, I've got 2. 2 times 1 is 2. That's 8. 2 times 4 is 8. Plus another 3 is 13. Whoops, plus 3 is 13, right? 10. Yep, that's 13. Those oxygens are stubborn. All right, I guess I got to go back over here. And this is going to become the next number up, which would be a 5. That's going to affect my hydrogen, my nitrogen, my oxygen. Let's go ahead and count them up. So I've got 5 hydrogen, and I've got 5 nitrogen, and I've got 15 oxygens. Wow. All right, let's go back over to the other side. And I'm going to try to fix my nitrogens, I think. So I'm going to put a 5 here. It was a 4. I'm going to jump it up to a 5. So that's going to change my nitrogens and my oxygens. So let's see here. That'll take this to 5 nitrogens. And it'll take me to 2 plus another 10 plus 3. That's 15 oxygens. And my hydrogens still aren't fixed. So I got to fix my hydrogens. I'm going to make that a 3. Oops, I keep the colors the same. Get rid of this scratch work up above here. So that's going to affect my hydrogen and my oxygen on this side. So let's see here. That gives me 2 times 3 is 6 hydrogens. And then I've got 3 plus 10. 2 times 5 is 10. Plus that is going to be 16 oxygens. Looks like my hydrogens are out of balance on this side. Wow, this is a long one going back and forth. So I'm going to make that a 6, which is going to change this, and this on my reactant side. So I'm going to keep counting. It's getting tedious. I've got 6 times 1 is 6 hydrogens, 6 nitrogens, and 18 oxygens. Well, my nitrogens are out of balance. Let me go over to the other side, get rid of my scratch work here. So I'm going to make that a 6, and that's going to affect my nitrogen and my oxygen. So let's go ahead and count things up here. I now have 6 nitrogens on this side, and I've got 3 plus 12, that's 15, plus another 3, that's 18 oxygens. Everything's in balance except for my aluminum. And I saved that for last on purpose. Boy, this is taking a long time. I've got 2 aluminums on this side, on my product side. I've got 1 aluminum, and when I change this aluminum, it's not going to change a thing, thank goodness. So let's go ahead and put a 2 out in front of that. That's going to change this to a 2. And yay, we're balanced. Let me double check this just to be sure. 2 aluminums, check. 6 hydrogens, 2 times 3 gives me 6 hydrogens, 6 nitrogens, 6 nitrogens, 18 oxygens. 3 times 6 is 18 oxygens. I've got, as far as the oxygens go, I've got 3 times 1 is 3, 2 times 6 is 12. That's equal to 15, plus another 3 from the aluminum oxide gives me a grand total of 18 oxygens. Yes, check, check, check. It is balanced. That was a long one. Sometimes they take that long.